Welcome, everyone. Today, for our research update, we have Dr. James Finley, Associate Professor here at USC. We've been fortunate to have him here for 10 years with us, and his research lab is the Locomotor Control Lab, as you can see here on the slide. And his major accomplishments that he's had thus far is lots of funding from NIH, the National Science Foundation, the American Heart Association, and also featured on the Netflix show Ada Twist Scientist, animated series aimed at encouraging children to develop an interest in STEM. Welcome, Dr. Finley, to Research Update in November 2023.
All right. Thank you, Lori, for the introduction. And so I'm excited to tell you all about a recent project in the lab that's funded by the National Science Foundation. And to motivate this project, I want you to imagine that you go out this weekend and you're deep in the Santa Monica Mountains or San Gabriel Mountains, and you're off to see a waterfall. And you reach a point on your hike where you have to make a choice. So you could take the path to the right that might be shorter, but a little bit treacherous. And so there's some risk that you may fall or injure yourself, or you could decide to go on the path to the left that might be longer and take more time. Alternatively, you might just decide that this is too effortful and give up and go home. So when we make these types of decisions that affect our mobility or that influence mobility, we may weigh different features of our experience based on either past history or what we observe. So these decisions might be influenced by things like the potential of falling, the time it takes to complete a task, or the amount of energy or effort required. And so while this is all fairly intuitive, one of the important things is that we don't really have a very rigorous understanding of how people make these decisions in the real world. And this is really important because these decisions that we make about where and how we move ultimately influence things like our overall health, but also the probability that we may fall and injure ourselves. And so this process of understanding how people make decisions is largely studied in the field of behavioral economics. And within this field, a lot of the current work and approaches used in behavioral economics have been largely influenced by the work of Danny Kahneman and Amos Tversky, looking at how we make these financial decisions when we're presented with options that might vary in the probability of different financial outcomes and the size of those outcomes. And one of the big pictures here is that we can examine the decisions that people make and use that information when combined with mathematical models to understand how people process information to inform those decisions. And so while in the lab, we're of course not interested in financial decisions, we're interested in decisions related to mobility. Instead of varying the amount of money people are able to receive, what we do is that we control things like risk and effort by varying features of our treadmill. So in the lab, we have a treadmill with two belts, and we're able to vary the speed of those belts independently. And we can either change the speed rapidly for a single or multiple steps to act as a balance perturbation, a slip or a trip, or we could change the overall speed of the treadmill and vary effort. And so what we do to understand people's decisions is that we give people two different experiences that vary in terms of their risk and effort, and we ask them to choose which one they would prefer to repeat. And similar to what I described about work in behavioral economics, we can take information about those decisions, how we're controlling the treadmill, how much their balance is disturbed, and we can model that data using mathematical models. And these allow us to understand how things like losses of balance, uncertainty or variability, and effort inform people's decisions. Now, just as a simple example, what we can do is we can extract numbers from these models that tell us about factors that influence people's decisions. And so here are some data that look at a particular measure from our model that has to do with people's sensitivity to risk. And so we have this individual, if we look on the left-hand side, these are data from 15 healthy young adults, but you see someone who's a bit of an outlier to the right. And what that reflects is that this individual tends to be more risk averse than other individuals. And we can not only do this at the individual level, but we can also look across a sample or population of people who come into our lab. And on the figure on the right, we can see that a lot of the people who we bring in tend to be risk averse. However, we also occasionally will find people who are risk seeking, and these are people who tend to choose things that might actually be more challenging. And so you can imagine that if someone has a risk seeking tendency, that might be something that puts them at a greater risk of falls. So in addition to the work that we're doing in the lab to really understand how people make decisions, one of the exciting things about this project is that we're also able to do some outreach. We have funding to do outreach, and we're working with Bravo Medical Magnet, and we're using games as a way to help students understand how people make these trade-offs between risk and effort during walking. So this game was something that we developed in collaboration with students in computer science here at USC. And one of the nice things is that our high school students can change the game. They can design their own experiments, test them with each other. And ultimately, we have the ability to allow them to analyze and visualize that data on their own. So overall, some of the major things that we hope to get from this work are that we really want to understand and figure out how we can determine individual risk-taking profiles, because these may influence fall risk. We can also use our measures to systematically identify people who might be overconfident or misjudge their balance ability. And ultimately, we want to use this work to examine how neurological impairments influence the decision that might affect people's fall risk. So with that, I will conclude by thanking my collaborators, particularly my co-investigator, Dr. Schweighofer, as well as Glendy Ramirez at Bravo Medical Magnet, as well as all the students and our funding. Thank you.